Hi, my name is Salahdin Zarro. I'm a cybersecurity major, and my showcase is about USB to OT intrusions. In this project, I look at how something very small like USB drive and one engineering workstation can be enough to move an attack from IT into OT and quietly change PLC logic in a power plant. First, a quick overview from the introduction box. The main problem is that USPs and engineering workstations can bridge attacks from IT to OT. The impact is serious. An attacker can change PLC logic quietly while the HMI still shows fake normal data that can damage equipment and affect safety and uptime. I use a Stuxnet style path as my example and map it into a simple incident response playbook. Prepare, detect, analyze, communicate, contain, recover, and learn. My goal is to suggest low cost controls that protect safety, keep the planet running, and support public trust. OT incidents don't happen every day, but when they do, the impact of one event can be very high. Now, the background. Power generation uses industrial control systems to run real machines on the planet floor. That's different from normal IT, which mostly handles data and business apps. IT and OT are linked through things like Windows engineering workstations, vendor remote access, and removable media such as USBs. OT security cares a lot about safety and availability, while IT usually focuses more on confidentiality and integrity of data. The difference is important. Stuxnet is my main case. It used multiple 0 days, stolen certificates, Windows rootkits, and it's spread by USB. It secretly reprogrammed PLCs while it showed normal reading. The big lesson is that engineering workstations become a critical point. That's why my poster focuses on USB and engineering workstation plus PLC. In the middle section, I show the main path. An affected USB is blocked into an engineering workstation. The malware lands on the engineering workstation. From there, the attacker can send unauthorized PLC logic to the controller. The operator, everything might still look normal, but inside the PLC, the logic has changed. The defense here is to control and scan removable media and to block unknown ones. I also connected this to the ICS cyber chain. Initial access through removable media, then literal movement across the network using infected Windows devices and remote services. I bring in MITRE ATT&CK to show that strong malware detection plus strict USB control could have broken Stuxnet chain early. Uh, in the middle of the poster, there is a unified IT/OT view diagram. The idea is that with a tool like Splink, we don't just look at one log at a time. We can bring together USB mounts, engineering workstation to PLC sessions, PLC file writes, vendor activity, and PLC logic hash drift. Seeing all this in one view make it easier to spot an IT to OT attack, you know, instead of chasing random alerts. At the bottom, I have my controls table. These are the key controls I recommend. Only allow listed USPs are used, especially on engineering workstations and vendor laptop. Use list privilege on engineering hosts so accounts can only do what they really need. Require two-person approval for important PLC logic changes. Keep golden images and backups offline for quick, clean restores. Monitor PLC logic hashes so we can see if the logic drifts from the baseline. And use an IT/OT dashboard so we can see both sides at the same time. On the right side is my contingency and response playbook. Prepare, set USB policy, enforce list privilege on engineering workstations, keep golden images and logic hashes. Detect, alert on USB mounts plus PLC path writes, alerts on off hours vendor logins on a new engineering workstation to PLC sessions and logic hash drift. Analyze, build a timeline using Active Directory logs, firewall logs, and engineering workstation HMI logs. Communicate, know in advance who talks to leadership, compliance, and the control room. Contain, disable risky accounts and isolate the engineering workstation if needed. Recover, restore from clean images and verify PLC logic against the baseline before restarting. Learn after the incident, update roles, refresh baselines, train staff, and improve the playbook. In the conclusion, next steps. The bottom line, USPs and engineering workstations are enough to move an attack from IT to OT and quietly change PLC logic. Next steps include stronger USB control, least privilege on engineering hosts, two-person approval for any important changes, clean images and backups, and unified monitoring. The goal is faster detection of unauthorized logic changes and safer, more controlled restores if something goes wrong. My showcase is really about powerful path from a USB to an engineering workstation to a PLC. If we control and monitor that path well, we can reduce the chance of a Stuxnet style incident and make power generation OT safer and more reliable. Thank you.